Hi everyone, welcome back to the Coding Interview Must-Know series. Today we're looking at a classic interview problem, Subarray Sum Equals K. The question is simple. You're given an integer array, and you need to count how many continuous subarrays have a sum exactly equal to k. Let's start with an easy example. Suppose the array is 1, 2, 3, and k equals 3. The valid subarrays are 1 plus 2 and also the single element 3. That gives us 2 subarrays. Now let's look at a slightly more interesting example that includes negative numbers. The array is 1, -1, 2, 3, -2, 4, and k equals 3. In this case, there are 3 valid subarrays. The first one is 1 plus -1 plus 2 plus 3 plus -2. The second one is just the single number 3, and the third one is 2 plus 3 plus -2. The most straightforward approach is brute force. We try every possible starting index, and for each start, try every possible ending index, and add up all the numbers in between. If the sum equals k, we increment our count. The benefit is that it's intuitive. The downside is that it's slow, because there are n starting points and n ending points, and we sum repeatedly, so the time complexity is close to n squared. So is there a smarter solution? Yes. And it's actually a very famous one. We use prefix sums combined with a HashMap. Here's the big idea. A prefix sum is the running total from the beginning of the array up to the current position. The key observation is, if the current prefix sum is s, and there was a previous prefix sum equal to s minus k, then the sum of the elements between those two positions is exactly k. So, as we iterate through the array, we keep a HashMap that stores how many times each prefix sum has appeared. Every time we reach a new position, we check how many prefix sums equal to s minus k we've seen so far. That number is exactly the number of subarrays ending here that have a sum equal to k. Let's walk through the example to see how this works. We iterate through the array while maintaining the running prefix sum, and we store counts of prefix sums in a HashMap. At the beginning, the prefix sum is 0, and we record that it appears once. When we see 1, the prefix sum becomes 1. 1 minus 3 is -2, which is not in the HashMap, so the count remains 0, and we record that prefix sum 1 appears once. Then we add -1, and the prefix sum becomes 0 again. 0 minus 3 is -3, not in the map, so the count stays 0, and we record that 0 now appears twice. Next we add 2, the prefix sum is 2, and 2 minus 3 is -1, not in the map, so we record 2 once. Then we add 3, and the prefix sum becomes 5. 5 minus 3 is 2, and 2 is in the HashMap once, so we found 1 valid subarray, and the count becomes 1. Record that 5 appears once. Then we add -2, and the prefix sum becomes 3. 3 minus 3 is 0, which has appeared twice, so we add 2 more to the count, and now the total is 3. Record that 3 appears once. Finally, we add 4, and the prefix sum becomes 7. 7 minus 3 is 4, which hasn't appeared, and we record 7 once. After finishing the scan, we found 3 valid subarrays in total. The Python implementation of this algorithm is actually quite simple. We create a HashMap that stores how many times each prefix sum occurs, and we initialize 0 to 1. Then, we iterate through the array while adding to the prefix sum. Each time, we check whether prefix sum minus k exists in the HashMap. If it does, we add its count to our answer. After that, we add the current prefix sum into the HashMap. With this approach, we only loop through the array once, so the time complexity is O of n. The extra space comes from the HashMap, so the space complexity is also O of n.